So here are the answers to the questions at the end of the previous chapter. Hopefully you've got all these right. So why don't you tick these off before we go on to electrical appliances. So this table shows a wide range of everyday electrical appliances and the energy transfers which take place within those appliances. So the device is supplied with electrical energy and then it changes it into other forms. Some of those changes are useful and some of them are not useful. You see in every case some of that electrical energy is changed into heat energy, whether that's the intended energy transfer or not. Power ratings. Now power is measured in watts. 1 watt, that's capital W, is a rate of transfer of energy of 1 joule per second. So 1 kilowatt, small k, capital W, is a rate of transfer of 1,000 joules per second, or 1 kilojoule per second. And you can calculate the power of an appliance. So the equation is P equals E over T, where P is power in watts. Be careful, in watts. E is energy transferred to the device in joules, not kilojoules, joules. And T is the time taken for the energy to be transferred in seconds, not minutes. You can calculate the amount of energy transferred to a device because appliances have a power rating which is normally found on the back or the underside. For example, if you look on the back of your kettle, you may find that it's got a power rating of 1.9 kilowatts or 2.1 kilowatts, something about there. Now this means it transfers 1.9 kilowatts of energy if it's switched on for an hour. Now the unit of energy supplied by mains electricity is the kilowatt hour, kWh, little k, big W, little h. So a 1 kilowatt heater, if it's switched on for an hour, uses 1 kilowatt hour of electrical energy. The same heater, if it's switched on for 2 hours, uses 2 kilowatt hours of electrical energy, and so on. Now when you start doing these calculations, it's always a good idea to estimate first, to check your answer is in the right sort of area. So if you've mixed up watts with kilowatts, for example, or joules with kilojoules, then you're going to find that your answer might have too many zeros or not enough zeros, so estimate in your head first. So really watch out. Is the question in watts or kilowatts? Because when you use that equation, you're supposed to be using it in watts. We can work out the cost of energy transferred. Electricity companies charge for electricity by the kilowatt hour, and they'll state the cost of it on your energy bills. So for example, the cost may be 7.9p per kilowatt hour. So the 1 kilowatt heater will therefore cost 7.9p if it's switched on for 1 hour, or 15.8p if it's switched on for 2 hours, and so on. So to work out the total cost, it's number of kilowatt hours used times cost per kilowatt hours. And just watch out, do they want the answer in pence or pounds? Okay, so quickly test yourself. Hopefully you've printed out all these notes so you can answer it now and find the answers at the beginning of the next chapter.